Characteristic number 2 is whether or not there's going to be a horizontal asymptote or an oblique asymptote. And we have already talked about the two situations with the horizontal asymptote. There is the easiest situation. The easiest situation is if the degree is larger in your denominator, you will always have a horizontal asymptote, and it will be at y equals 0. So this is situation number 1. It's super easy. I don't even go into the explanations that the textbook goes into. It's, right? If x gets really, really big, you divide a number by a big number, it's going to get close to 0. So that's why that's a super easy one to tell if there's a horizontal asymptote at y equals 0. Situation number 2. If the degree is the same on the top and the bottom, you will have a horizontal asymptote. And all you have to do is look at the leading coefficients. In this case, it would be at y equals 2. They try to explain it with synthetic division. We don't have to get that complicated. If the degree is the same on the top and the bottom, you're going to have a horizontal asymptote at whatever this simplifies to. And the idea behind it is if x got really, really big, the -3 and the -1 wouldn't make much of a difference. You would basically have 2 times something divided by something. The top, when x is really big, can you see that the top is basically double the bottom? Even if this was subtract 1,000, it wouldn't matter when you're dealing in the trillions, right? If I make $1 trillion, Sam, I'll give you $1,000. It wouldn't bother me at all, right? I'm working on it. Well, don't get too excited anytime soon. But it wouldn't really matter to me at that point, right? And then the third situation which we haven't looked at if the degree is larger on the top after simplify. It is not early dismissal. They are confused, but wait for the announcement in 3 seconds. Okay, they're a little slow. Maybe it is. I should just let you guys go, right? Yeah.
Sorry for the interruption. That is not a change of period. This 5th period will go till 2:19 as regular scheduled. That is not a change of period. We're sorry for the inconvenience.
Oh, all these students who had their hopes go up only to be crushed. Okay. And here I was thinking, wow, I really mistimed my lesson today. I was like, I can't believe we were just in the middle of this when it was. Okay. So if the degree is larger after simplifying, because if we go back to our example 1, I just want to show you example 1 that we did. Let's just go back and look at example 1 that we did. Do you see in example 1 the degree was bigger on the top? Okay? That is technically, the situation is possible for an oblique asymptote in that case. But it's simplified oh yeah, we erased the work, but remember that that one's simplified, and it went away. So that's why in the notes it says here, if the degree is bigger on the top after simplifying, then you have an oblique asymptote. And to find it, this is perfect because you have this on your test tomorrow. Use synthetic division to find it. So how does that work? Well, you actually do x squared divided by x plus 1. With synthetic division, x squared would be 1, 0, and 0, right? I have to add zeros because there's no x's and there's no 1s. And if you were dividing by x plus 1, you would put a minus 1 out front. Bring down the 1, multiply, add, multiply, add. And the division statement, or the quotient that you get, is x minus 1 remainder 1, and you can just ignore whatever the remainder was, just ignore it. That is the equation of your oblique asymptote. Whatever the answer is after you divide is your oblique asymptote. Okay, so now we can go to example 2, where we can graph these things completely and see, do some of them have oblique asymptotes or horizontal asymptotes? Again, it just asks about the asymptotes, but we're going to graph it completely. So here's part A. When graphing a rational function, do we need to have we could steal our steps even, edit, copy, just so that, even though we can't read them, they're sort of there. Step number 1, we have to factor completely. Can I factor this equation? Yes, the top can factor to x plus 7, x minus 1. The bottom is x plus 2. Does anything simplify? No. When we're going about, after factoring, when we're going about graphing, the very first thing we always list is our non-permissible values. In this case, x can't equal -2. And we have to decide if that non-permissible value is a vertical asymptote or a hole. Since it didn't go away, it will be a vertical asymptote at x equals 2. So when we label our asymptotes, they're always an equal sign. When we talk about non-permissible values, that's when we say the not equals in there. X can't equal -2, but the equation of the asymptote is x equals -2. Okay? This one, can you see the degree is bigger on the top? Yeah, oh, sorry, I just forgot that. No, that's right, there should be a little minus sign. Thank you. X equals, that looks correct. That's much better. Thank you. So since the degree is bigger on the top than the bottom, can you see you have a parabola on the top, a line on the bottom, and nothing simplified, this is where you have an oblique asymptote. Where is that oblique asymptote? We have to use synthetic division to find it. We are dividing the original equation, 1x squared, 6x minus 7, dividing by x plus 2, so you put a -2 up front, bring down the 1, multiply, add, multiply. You can ignore the remainder. The oblique asymptote will be at y equals x plus 4. The remainder of -15 doesn't make a difference. So we can start to draw our graph. What do we know on our graph? We know that at -2, we have a vertical asymptote. And we have an oblique asymptote, and our oblique asymptote is a straight line with a y-intercept of 4 and a slope of 1 over 1 down 1. So we've drawn both of our asymptotes. Now we just need to have some nice points, which means we need to find our y-intercept and our x-intercept. Again, the y-intercept is usually the easiest to find. Plug in 0 for x. And the x-intercept is when you plug in 0 for y. Now, plugging in 0 for x, I would go back to my original equation. Can you see that the top would just be -7? The bottom would be +2. -7 over 2 is our y-intercept. 1, 2, 3, 4. Which is -3.5. There is our y-intercept. Okay. X-intercept, you would plug in 0 for y. If I plug in 0 for y, and I look at my factored equation, I had x plus 7, x minus 1 over x plus 2. Algebraically, you should be able to just write them out. There's going to be 2 of them. Because the only place a fraction equals 0 is if the top is equal to 0. I can multiply both sides by x plus 2 right now and just get rid of the bottom. And it's already factored for us. So we can see that one of them has to be at -7 and the other one at +1. So I go to my graph. 1, 2, 3, 4. And I can label -7, 0 and 1, 0. Now, in the nice points section, it says you need at least 1 point per section. And this is where sometimes students get a little bit confused. Because they would say, okay, we have points in this section, I have a point over here, but maybe I don't have a point in this section. Okay? That's actually a mistake. The sections are only split up by your vertical asymptote. This one has 2 sections. The section when x is on this side of -2, and the section when x is on this side of -2. It only has 2 sections. Do we have a point in section 1? Yes. -7, 0. Do we have a point in section 2? We actually have 2. We do not need any more points. We are ready to draw the graph. All you have to do to draw the graph is make your graph go towards the asymptotes. This one here will go towards the asymptote here, and will go towards the asymptote there. It's really kind of awkward. But that's enough to draw this graph. It's a weird looking graph, definitely. Okay? You can't introduce any new x-intercepts, and you just have to draw the graph towards the asymptotes. So the rules for graphing these stay the same, but the graphs themselves look really different. And that's kind of an awkward thing about these. Once everybody's done this one, let me know. I'm going to erase it and then do part B on the same one. Is everybody good, or is anybody still working on stuff? Eli, are you still working on it? Yeah. Okay, just let me know when you're done. that part B is going to be really easy to factor because it's exactly the same. X plus 7, x minus 1. Things have just been flipped. Nothing cancels out. Non-permissible values. X can't equal -7 and x can't equal 1. Those would be both vertical asymptotes in this situation because they didn't cancel out. The degree is larger on the bottom. You have a parabola on the bottom, a line on the top. When the degree is larger on the bottom, that's the easiest one. You have a horizontal asymptote at y equals 0. Because as x gets big, the squaring means that the bottom will get bigger much faster than the top. Can you see that? Like if I put in 100 for x, ooh, the top is pretty big, it's at 102, but the bottom is going to be already over 10,000 because it's getting squared. So we have a horizontal asymptote at y equals 0. Once you have all of your asymptotes, we can start x equals -7, x equals 1, and y equals 0. Now we get to our nice points. We have to find our intercepts. Again, the y-intercept is the easiest one. Plug in 0 for x. What do you get? 2 on the top, -7 on the bottom. So we get 2 over -2/7 as our y-intercept. X-intercept. Okay? Here's something that's going to maybe bother you a little bit. I don't mind if it bothers you a little bit. How do we find an x-intercept? We plug in 0 for y. Okay? So if I plug in 0 for y, I would have x minus 7, x plus 1 on the bottom, and I have x plus 2 on the top. Where's the only place a fraction can equal 0? Is if the numerator equals 0. I mean, you can multiply both sides by x minus 7 and both sides by x plus 1 to cancel out the bottom. And then you will get an x-intercept at -2. Why did I say that would bother you? Well, let me just graph it. See if it bothers you. That bother you? Does it bother you that you have a point on an asymptote? Oh, a little bit, eh? It can happen for horizontal asymptotes. It can never happen for vertical asymptotes because vertical asymptotes tell us non-permissible values. Horizontal asymptotes are there to tell us what happens when x gets really big, positive, or really big negative. In the middle, though, it's like, yeah, if you want to go through me, it's okay. So we sometimes have values that go through an asymptote in the middle. Can you see that this one with our vertical asymptotes is separated into 3 sections? Can you see that you have no points in section 1 and no points in section 3? So we have to find some nice points. In section 1, since x is -7, I might try to plug in -8. If you plug in, here I'll even label this section, nice points. If you plug in -8, what would we get? Did I write down, it's x plus 7. I use the factored one because it's pretty easy to do the mental math. What's negative 8 plus 2? Minus 6. I have minus 6 on the top. And on the bottom, this would be minus 1 and minus 9, positive 9 on the bottom. So I get negative 8, and then I'd have negative 6 over positive 9, which is negative 2/3. I can add that point on the graph. Negative 8, negative 2/3. And once I have that one point in that section, I know that that section looks like that. I'm kind of excited about what's going to happen next. Now, in the middle section, you have some points. First of all, would you agree that these points are going to have to connect? Then, you have an option that this goes down towards the asymptote or up. But if it goes up, can you see that you would make another x-intercept? And we've found all the x-intercepts possible, so it has to go down. But now we have an issue over here, because it could bounce and go down, or it could go through and go up. If we wanted to make sure, we could do another nice point. So for example, we could plug in one of these points. Negative 3, negative 4, negative 5, maybe even negative 6, really close. So let's say I plug in negative 6. I go to my factored one. Can you see that the top would be minus 4, and the bottom 1
and
minus 7, which will be positive 4 sevenths. And the reason that's important is that tells me that this goes up towards the asymptote and doesn't bounce and go down. Now you could probably tell that it went through, because what's the multiplicity of that 0? It happens only once. So it had to go through instead of bounce. If this was an x plus 2 squared, it would bounce. So we have some of the things from chapter 1 coming back and showing us things again in chapter 2. We still need one more nice point. I'm going to plug in positive 2, something in section 3. I go to my factored one. Can you see that the top would be 4? And on the bottom, I would have 9 times 1, positive 4 ninths. So I would have 2, 4 ninths, and that's enough to draw that section. So this example, we need to define lots of nice points in order to graph it all. The previous one, the x-intercepts and y-intercepts, was enough to do everything. All right, so I will get you to circle questions 6 and 7. I know that they ask you specific things in these first questions, like only to find the horizontal asymptotes or only to find the vertical asymptotes, but to practice, you should graph every single one you come across. So in 5, 6, and 7, graph all of those equations. And if you're ever, the answer key will not have the graph, but that's the power of having Desmos on your phone. You can type it into Desmos and see what the graph is supposed to look like to see if yours matches. Now we have 8 minutes left. I'm not going to do another example. Just talk a little bit about the test tomorrow.